In this video, we're going to do a walkthrough of solving a system of linear inequalities. And at the end, you'll get to practice on your own with a similar problem. So let's get started. So for this practice problem, we're asked to solve the following system. We have two inequalities, 2x plus y less than or equal to 4, and x plus 2y greater than or equal to 4. So when we solve this system, what we're doing is graphing this system of inequalities. And we'll start by graphing this first inequality. So to graph this first inequality, the first thing I do is I write the boundary line. So I'm going to rewrite the inequality as an equation, 2x plus y equal to 4. And now we're going to graph this line. Again, this is written in standard form. When I have an equation written in standard form, my go-to methods for graphing this are to either convert this to slope-intercept form or to find the x and y intercepts. For this line, I'm going to convert this to slope-intercept form because I can do this in one step. Subtracting 2x from both sides results in y equal to negative 2x plus 4. And so we now have a line in slope-intercept form. We have a y-intercept of 4. So that's the ordered pair 0, 4. And we can plot that point. And we have a slope of negative 2. So writing this as a fraction, we can go negative 2 all over 1. So we'll go down 2 and to the right 1. So from that y-intercept, we're going to go down 2 to the right 1. Let's repeat that one more time. Down 2 and to the right 1. So we now have 3 points on the boundary line. So let's draw our line. Notice that this is a solid line because we have less than or equal to. The points on this line will be included in the solution. Now we need to determine which side of the line to shade. And we do this by picking a point on each side. So any point will work as long as it's not on this boundary line. So keeping our arithmetic simple, I will typically pick the origin if that's available. So let's test the origin, 0, 0. We're going to plug that into that first inequality. So we have 2 times 0 plus 0 less than or equal to 4. Well, this is 0 plus 0 less than or equal to 4. So 0 less than or equal to 4. And that's a true statement. So if the ordered pair 0, 0 results in a true statement, then all the ordered pairs on that side of the boundary line will also result in a true statement when we plug it back into this inequality. Now I am going to go ahead and check another point on the opposite side. This should not result in a true statement. So let's do 3, 3. So we'll test the ordered pair 3, 3. We now have 2 times 3 plus 3 less than or equal to 4. 6 plus 3 less than or equal to 4. 9 less than or equal to 4. Again, that's a false statement. That's not true. Now I got a true statement with the first ordered pair I tested. But I went ahead and checked the other side of that boundary line just to confirm. It's kind of a quick check that I didn't make any arithmetic mistakes. So from this information, I know I'm going to shade this side of the boundary line. So now we have graphed this first inequality. So I left what I needed for this first inequality. What I needed was the boundary line and then the side of the boundary line that needs to be shaded. Now we're going to repeat these steps with the second inequality. So I'll start with writing the boundary line for this inequality, x plus 2y equal to 4. And now we're going to graph this boundary line. This boundary line is also written in standard form. There are a number of ways we can graph this line. We can convert this to slope-intercept form, but it would take 2 steps. We'd subtract the x from both sides, and then divide both sides by 2. Another way of graphing this line is to find the x and y intercept. And this is a convenient way of graphing lines that are written in standard form, particularly when this constant, this number by itself, in this case 4, if it's divisible by both the coefficient of x and the coefficient of y, finding those x and y intercepts is a great way of graphing this line, because you'll end up with an integer for the x and y intercepts. So let's find those intercepts. So for our y-intercept, our x value is 0. So we have 0 plus 2y equal to 4. This gives us 2y equal to 4 and y equal to 2. So our y-intercept is the ordered pair 0, 2. And then to get that second point, our x-intercept, we set y equal to 0. Now we have x plus 2 times 0 equal to 4. This is x plus 0 equal to 4. So we have x equal to 4. This is the ordered pair 4, 0. We have 2 points, and all we need are 2 points to graph our line. So let's draw that boundary line. This boundary line is also a solid line because this is greater than or equal to. All these ordered pairs that are on the line are solutions to this inequality. And then as before, we need to pick a point on each side of the boundary line to determine which side to shade. So let's pick 0, 0 for one side. So we're going to test 0, 0 on this second inequality. This is 0 plus 2 times 0 greater than or equal to 4. So we have 0 plus 0 greater than or equal to 4. 0 greater than or equal to 4. And that is not true. Process of elimination tells us that if it's not the side that contains 0, 0, it has to be the other side, but we're going to test a point over there anyway. Let's try 3, 3. So testing the ordered pair 3, 3, we have 3 plus 2 times 3 greater than or equal to 4. 3 plus 6 greater than or equal to 4. 9 greater than or equal to 4. And that's a true statement. So we're going to shade the side of the boundary line that contains the ordered pair 3, 3. Now we have 2 boundary lines, and we know which side of the boundary lines to shade. And so the solution to this system, or the graph of this system of linear inequalities, is that region where they overlap. So that is the region we will shade. So the solution to this system includes all the ordered pairs, all these points in the shaded region, the points on both boundary lines, up until the point where these 2 lines intersect, where they cross each other. This point of intersection is also included in the solution. Now continuing on these boundary lines, once you get past the point of intersection, so once you get past where these 2 lines cross, these points on the boundary lines are not a part of the solution. So a quick review of the steps involved in solving systems of linear inequalities. Again, this is graphing this system. We're going to graph the first inequality and lightly shade or somehow indicate the correct side of the boundary line. Repeat that process with the second inequality. Shade that overlapping region. This region is the solution to the system. And then we can check a test point within the solution. So testing a point in this region, let's try -1, 4. So we'll test -1, 4. For this first inequality, we have 2 times -1 plus 4 less than or equal to 4. This is -2 plus 4 less than or equal to 4. 2 less than or equal to 4. It's a true statement. Then with the second inequality, we have x plus 2y. So that's negative 1 plus 2 times 4 greater than or equal to 4. Negative 1 plus 8 greater than or equal to 4. 7 greater than or equal to 4. That is also a true statement. So this is the graph of the system of linear inequalities. It's also the solution. It's all the ordered pairs that when we plug into these inequalities will give a true statement for both inequalities. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do this problem. So for solving this system, the first step was to graph this first inequality. So from this inequality, we get our boundary line. All we needed was one step to convert this to slope-intercept form. So I went ahead and converted this equation into slope-intercept form. We have a slope of negative 1 and a y-intercept of 3. And so we graph this line. And then when we draw this boundary line, we draw it as a dashed line because the points that are on this line are not included in the solution. The points on this line, if we plug them back into this inequality, will not result in a true statement. And we can see that with the y-intercept itself. If we plug this y-intercept in, we would have 0 plus 3 less than 3. Well, this is 3 less than 3. That's not true. 3 is not less than 3. 3 is equal to 3. We have our boundary line, so now let's test a point on each side. Again, I'll start with 0, 0. Plugging the ordered pair 0, 0 into this first inequality, we end up with 0 less than 3. That's a true statement. But let's confirm by testing a point on the opposite side. We should get a false statement. Let's try the ordered pair 2, 4. Plugging this ordered pair into the first inequality, we end up with 6 less than 3. And that is false. That is not a true statement. So we're going to shade the side of the boundary line that contains the point 0, 0. All of these points in this region are solutions to this first inequality. So I went ahead and cleared up this graph. All we need is the boundary line, and we need to know which side of this boundary line is shaded. And we're going to repeat this with this second inequality. So we have x minus y less than or equal to 3. Converting this into slope-intercept would take a few more steps. And since 3 is divisible by both 1 and negative 1, I went ahead and found both the y-intercept at x equal to 0 and the x-intercept at y equal to 0 to graph this line. It is a solid line because it's less than or equal to. The points on this line are included in the solution to this inequality. So we have our boundary line, and now it's time to test a point on each side. Again, I'll pick 0, 0. Plugging that into that second inequality, we end up with 0 less than or equal to 3. That's a true statement, but we will go ahead and test a point on the other side. Let's test this point on the x-axis, 4, 0. When we plug this in, we get 4 less than or equal to 3, and that is not a true statement. So we'll shade the region that contains the ordered pair 0, 0, that origin. So the solution to the system will be this overlapping region. And then in this case, where these lines cross is not included in the solution because it's on that first line, x plus y less than 3. Drop any questions you have in the comments. Continue practicing solving systems of linear inequalities, and I'll see you in the next video.